It's Daniel Marconi, and this is my presentation for Physics 2 Lab 1. The purpose of this lab was to measure the magnitude of excess charge on everyday objects. The physics principles used were the gravitational force, electric force, second law of motion, and these were tested experimentally, and then data was input into a computer model. As a preview of the results, I found a value for the magnitude of charge on the tape. The first physics principle I used was the second law of motion, which states that force equals mass times acceleration. No net force from the gravity and electric repulsion means no acceleration in the tape. And this was used to explain how no net force would affect the velocity of an object, in this case the tape, not changing in its velocity of zero. Force of gravity is equal in magnitude and opposite in direction to electric force. The principle I used was gravitational force, which is the force due to the attraction of mass to mass. For systems that are interacting with the surroundings that include the Earth, this is given by the force of gravity equals mass times gravitational acceleration. And this was the force that pushed tape 2 down and was the force that caused the tape hanging across the bottles to hang. The principle I used was the electric force, which is the force due to the interaction between charged particles. This force repelled the tapes away from each other, allowing tape 2 to float. And this happened because each tape had a non-zero net charge of the same sign, which caused them to repel each other. For the experiment, the surroundings were the Earth and tape 1, which is the lower tape, and the system was tape 2, which was the higher tape. To do this experiment, I used a base tape stuck onto a table, and I put an upper tape stuck right on top of it and ripped it off quickly. Doing that twice with a separate piece of tape, I was able to create two pieces of tape that both had a positive net charge, which I found because they repelled each other and they were attracted to a negatively charged pencil that I rubbed in my hair. One tape was placed on top of two perfume bottles and left to hang while the other upper tape was placed below it. I moved the lower tape up until the upper tape on the bottles floated upward, and I measured the distance between the two. For the coding, I used GlowScript to model this, and these are the observed initial conditions and the calculated magnitude of force of gravity and magnitude of electric force, which are both equal to each other. I approximated the tapes as point charges on top of each other because doing so otherwise would have been too complicated. And I produced a set of values for the net charge on tape 1 and 2, number of reduced electrons, and number of reduced electrons per atom, since the tapes had fewer electrons than they started with. This was the code that I used, and here you can see the initial conditions at the beginning and constants, the object creation, the tape constants, calculations to find the charge on one of the pieces of tape, and the arrows that represent the force of gravity and electric force, and extra calculations to show the number of fewer electrons and number of fewer electrons per atom. Because the tape was attracted to the negatively charged pencil, the tape must have had a positive charge and therefore missing electrons. The prediction of electric repulsion between the two similarly charged tapes was shown in the model. Net charge on each piece of tape was 1.29 times 10 to the negative 8th coulombs. The number of fewer electrons on each piece of tape was 8.07 times 10 to the 10th electrons missing, and the number of fewer electrons per atom in the tape was 2.37 times 10 to the negative 7 electrons missing per atom. The magnitude of the charge on one piece of tape was 1.29 times 10 to the negative 8th coulombs. Assumptions, approximations, and idealizations made to determine this charge were me treating the upper tapes as if they were point charges with all charge concentrated at the centers of the tape, and I assumed each upper tapes had the same amounts of charge evenly distributed along the length of the tape. Possible sources of error include inaccurate measurement of the separation distance between the two tapes, which would be random error, and also some of the tape 2's weight was supported by the bottles used to hold it up, meaning that less electric force was needed to be used to push it upwards, which would have been a systemic error. If the electrons had a positive charge and the protons had a negative charge, nothing would change about the observations that I made with the tape or other charged objects, because positive and negative are just made-up concepts that are used to explain opposing charges. So switching the signs on everything would still cause the like charges to repel, like the tapes and the pencil, and opposite charges to attract. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? It's important to handle the charged tapes as little as possible so the charges on them don't get neutralized by contact with other objects, which act like grounding lines, causing electrons to jump from them to the tapes, neutralizing the objects, making them less positively charged, which reduces the electric force repulsion between the tapes. Thank you.